Hello everyone. In this lecture, I'm going to show you how to calculate the quadrupole moment. For this purpose, I'm considering the simplest of its kind, that is the linear quadrupole. So, linear quadrupole is an arrangement of three charges. Let me take this as the z-axis, and this as y, this as the x-axis. Okay, in this I'm taking a charge q at this point, which has coordinates 0, 0 and another positive charge over here q, which has coordinate 0, 0 and minus a, and I'm considering a charge minus 2q at origin of this coordinate system. So this configuration we call it as quadrupole. So for this quadrupole, I wanted to calculate what is the total potential at a point P, which is at a very far away distance from the origin. At this point, okay, I wanted to calculate the total potential. So total potential at this point, according to multipole expansion theory, is contributed by monopole, dipole as well as quadrupole. So first I am calculating the contribution due to monopole term. For this purpose, I would like to proceed like this. The expression for monopole moment Q is equal to, what is the expression for monopole moment? Summation over alpha Q alpha. What is alpha here? Alpha is the index which gives the charge, index related to charge. When alpha is equal to 1, Q1. When alpha is equal to Q2. When alpha is equal to 3, Q3. That is equal to. So when alpha is equal to 1, what is the value of charge? Q. Plus when alpha is equal to, charge is minus 2Q. Plus when alpha is equal to 3, charge is again Q. Because of which total monopole moment is 0. That implies potential due to monopole, V mono, as total charge is 0, contribution to the potential also 0. And second term that I am going to calculate here is, this is first term. Second term that I am going to calculate here is dipole term. Okay, second term dipole. So therefore, from the definition of dipole moment, P bar is equal to, what I can write, summation over alpha Q alpha into R alpha. What is Q alpha? Charge. When alpha is equal to 1, Q1. What is alpha? R alpha? Coordinates of the charge with respect to the origin. Okay, let me call it as dash, because for source I am using primed coordinates. For field point I will be using unprimed coordinate, which is a general convention. Okay, R alpha dash means the position of the source. What is the source here? Charge Q. So when alpha is equal to 1, it is the position coordinate corresponding to charge Q. Okay, that only I am writing here. That is equal to, when alpha is equal to 1, this is Q. Q into its position with respect to the origin is how much? A. Plus. Next, when alpha is equal to 2, charge is minus 2Q. And its charge is how much? Its location is 0. Our position of this charge with respect to the origin is 0. Plus when alpha is equal to 3, what is the value of charge here? Q, and its coordinate is minus a. Its location is minus a. So altogether Q into a QA and minus Q, altogether this term also 0. So as total dipole moment is 0, what happens? The potential due to dipole, contribution to the potential by dipole, V dipole also 0, 1. Okay, like this we calculated monopole term and potential due to monopole, dipole term and potential due to dipole. Now I am going to calculate contribution to quadrupole moment. So for this purpose, first I should define quadrupole. What is quadrupole? I should define what is quadrupole. Okay, so for a discrete charge system, what is the expression for quadrupole? Q I j is equal to summation over q alpha into 3 xi alpha and xj alpha minus r square into delta ij. Okay, this is the definition of quadrupole moment for discrete charge system. So what are these I and j? I and j are indices of the coordinates of charge. For example, if you take alpha is equal to 1, and that means this charge. And what does this ij represent? When I is equal to 1, I is equal to 1 and j is equal to 1 represents xx term. Okay, and when I is equal to 1 and j is equal to 2, what does it represent? Yy term. Okay, when I is equal to 2 and j is equal to 2, I is equal to 1, j is equal to 2 is xy term, sorry. When I is equal to j is equal to, it represents yy term. Okay, so this I and j are running for the coordinates of this chart. Indices coordinate indices. Okay, so first I am taking when I is equal to 1, j is equal to 1, that I am calling it as q11 term. Q11 is equal to, first you take alpha is equal to 1 is how much? Q into, okay, xi of alpha. Actually I should use primary coordinates for what you call it as source field. So xi alpha dash, xj alpha dash. Okay, so here alpha is equal to 1, that is for charge number 1. Xi dash, I is equal to how much I have taken here? 1 is how much? X value of this charge 0, 3 into 0 into xj, j also here how much? J is equal to also 1, so this is also 0 minus r square, distance of this charge from here to here is how much? A, that is a square into delta ij, it is canonical delta symbol. Okay, when I is equal to j, delta ij value is 1, so here I is equal to j is equal to 1, so delta ij value is 1. I think you understood how I calculated for charge number 1. Similarly we can write down for the second charge also. Next, alpha is equal to means second charge 2q into 3 into, okay, for this charge both x, y, z all coordinates are 0. 1 means x coordinate 0 and again x coordinate 0 minus its distance also is 0, so altogether this is for alpha is equal to. Next I am going for alpha is equal to 3. Alpha is equal to 3 means this charge, so plus q into, okay, 3 into, yeah, I is equal to j is equal to 1. 1 means xx, x coordinate value is 0 and another x coordinate value also 0 minus a square, because r square, distance of this charge from the origin is minus a whole square is a square into delta ij, I is equal to j is equal to 1, because of which again it is 1. That is equal to how much you gonna get here? So this term altogether, this term is 0 only, so this term how much you will be getting here? 3 into minus 3 into 0 is 0 is minus qa square. Here also again you are getting 1 minus 2a minus qa square. Altogether you will be getting minus 2q into a square. Okay, next I am calculating q22 is equal to 2 means 2 index means I is equal to j is equal to 2. So again take alpha is equal to q into 3 into xi, where is this xi alpha dash x dash j alpha. So here xi is equal to what I considered here 2. 2 stands for which coordinate here? Y. So here x in general represents position, it is not x coordinate. Okay, so I is the index which represents the coordinate, so I is equal to 2 represents y coordinate. Y coordinate of this charge q is how much? 0 minus a, the distance of this charge is a square into delta ij, I is equal to j is equal to 2. When I is equal to j, delta ij value is 1 only, minus 2q into, when alpha is equal to second charge you should take 3 into, altogether this term is 0 minus, okay, so here this distance of this charge is 0, because of which 0 into 1. Next alpha is equal to 3 means this third charge, that is plus q into 3 into s. What is the y coordinate of this charge? That is also 0. Everything is 0, 0 minus r square, distance from here to here is a, which is a square into here I is equal j is equal to, so when I is equal j is equal to, same I and j same index, if they carry same index means value is 1, delta ij value is 1. This is how. So q22 value also, how much we got? Q into minus a square, q into minus a square, altogether minus 2q into a square we got. Okay, similarly calculate for q33. I'm going to calculate here q33 means 3, third index, second index is y axis means I is equal to 3 and j is equal to 3 means it is zz term. So q33, which is nothing but qzz is equal to, first q alpha is equal to 1 means q into, okay, 3 into, now so xi alpha dash, alpha is equal to 1, here I is equal to how much it is? 3. So third coordinate of this charge is how much? A into, both zz terms only, no, a into a, minus distance of this charge from the origin is a square, into, when I is equal to j, same value, same index if they carry, delta ij value is 1. Next, when alpha is equal to 2, this is second charge, that is minus 2q into 3 into, yes, z coordinate of this charge minus 2, which is at origin, is obviously it is 0 into 0 minus what is the distance? That is 0 into delta ij value is 1. Next, plus when alpha is equal to 3, that is third charge, that is plus q into 3 into, yeah. So what is the z coordinate of this particle? Because I is equal to 3 means z coordinate is how much? Minus a into, again minus a into, minus, what is the distance of this particle from the origin? A square into delta ij value, when I is equal to j is equal to 3, delta ij value is again 1. So that is equal to, how much you going to get here? This term altogether, this term is 0. So only this term contributes. 3a into a square, 3a square minus a square is 2a square. Again this is minus into minus plus, 3a square minus a square, 2a square, 2 plus 2 4. So 4q a square. This is qzz. Now you calculate q12, which I call it as qxy. So blindly I can say that here all these terms will vanish. Let me check whether it is true or not. Okay, qxy is equal to q alpha is equal to 1 is q into 3 into, yes, x I is equal to 1 means x coordinate of this charge. X coordinate of this charge is 0 into y. Y coordinate of this charge is again 0 minus, okay, for all these xy off diagonal elements I is not equal to j, because of which this delta ij r dash square delta ij term will be 0 only. Minus 2q into, when alpha is equal to minus 2q into, yes. So for this again 3 into, x is equal to y is equal to 0 only for all, because all coordinates are 0 for this charge. When alpha is equal to 3, you take plus q into 3 into, yes, I is equal to x coordinate 0, j is equal to y coordinate 0, because again it is 0 0. Like this, all these off diagonal elements are 0. So through this what I can write? Q xy is equal to q yz is equal to q xz is equal to so and so. All these off diagonal terms will vanish and they will contribute 0 dipole moment. Okay, this is how I calculated all the quadrupole moment terms. So if you write down the quadrupole moment tensor q I j is equal to, how much you will be getting? First qxx, here you will be getting qxx, next qxy, next qxz, and then qyx, next qyy, next qyz, next qzx, next qzy, next qzz. This is the quadrupole moment term. That implies quadrupole moment tensor qij is equal to, what you're going to get? Qxx. What is the value of qxx? You got minus 2q a square. That only I am taking here. Minus 2q a square. And qxy value is 0. qxz value also 0 of diagonal terms, and qyx also 0, and diagonal element qyy, that is qyy q to 2 minus 2q alpha square minus 2q a square, and this is 0, and again this is off diagonal element 0, this also 0. Next qzz, how much I got? 4q a square. Okay, this is how we calculated the quadrupole moment tensor. So what is the expression for potential due to quadrupole? V as a function of r theta if possible phi is equal to, what I can write, 1 by 4 pi epsilon naught into summation over, okay, xi xj divided by 2r power 5 into qij. So here I did not use any primes because these are the coordinates of field point, not the source point, because of which I did not use any primes over there. That is equal to, what I can write, that is equal to 1 by 4 pi epsilon naught, 1 by 2r power 5, I am putting outside the summation, 2r power 5 into, okay, when I is equal to j is equal to 1, what you will be getting? X into x, you will be getting q x into xy, okay, plus, next, when I is equal to 2, j is equal to, you will be getting q, what you call it as y into y into y. So here I should use x, I wrote y, okay. Like this we will be getting all terms. When next I is equal to j is equal to 3, you will be getting q z into z plus, next, when I is equal to 1, j is equal to half diagonal elements, q xy into x into y plus so and so, all half diagonal elements. So like this you will be getting. I am not writing half diagonal elements because anyhow all the half diagonal elements are 0, okay. So that is equal to how much you will be getting? 1 by 4 pi epsilon naught into 1 by 2r power 5 into, what is the value of qxx? Qxx value is how much? Minus 2q a square, minus 2q a square into x you will be getting x square, plus qyy value is how much? Minus 2q a square into y you will be getting y square. Next, plus qzz value, how much you got here? 4q a square. So 4q a square into z square, plus qxy value is 0, all the remaining terms are 0, all the remaining 6 terms they will be 0, because of which I am not writing out there. That is equal to, I am taking 2q a square common, 2q a square divided by 4 pi epsilon naught into 2r power 5 into s. As I've taken 2q a square common, what you will be getting? 2z square is left over here, 2z square minus x square minus y square. This is the term. Here I will do one thing, I will add one z square over here and I will remove one z square over here, because of which I can write it as, this whole thing as x square plus y square plus z square, if you take minus as common, which is r square, that I am writing here, that is equal to 2q a square divided by 4 pi epsilon naught into 2r power 5 into, this I can write it as z, 2z square plus z square is 3z square, this is minus half x square plus y square plus z square, which I am writing it as r square, okay. Next, in spherical polar coordinates, what is the value of z in terms of rectangular polar coordinates? The relationship between rectangular and polar, z is equal to what you can write? R cos theta only. So that only I am substituting here. If you substitute here, you can take r square, because z square is r square cos square theta, you can take it out. That only I am writing. 2 1s are 2 2s are. So q a square divided by 2 pi epsilon naught into, in this r square I am pulling it outside, r square r power 5 gets cancelled, because of which you can write it as 1 by r cube, and this 2 I am taking into this one, because of which you will be getting 3 cos square theta minus 1 divided by 2. Why I wrote it like this? Because this whole term is nothing but P2 of cos theta, Legendre, second term of the Legendre polynomials. Am I right? So for writing that only, I did all this manipulation. Actually, we got answer over here only. I'm doing simple manipulation such that answer may look somewhat simple. That is equal to what you can write. Okay, Q a square divided by 4 pi epsilon naught r cube into P2 of cos theta. So here I wrote V as a function of r comma theta and phi. So for a linear dipole, it is independent of phi. For a planar dipole, it depends on phi, because of which I am omitting and I am writing it as potential due to quadrupole moment as a function of r comma theta is given by, this is the expression. Okay, therefore total potential at P is given by, therefore total potential V is equal V total at r and theta is given by. Directly I can write it, because just now I showed you potential due to monopole is 0, potential due to dipole also 0. Only thing that contributes to the total potential is this quadrupole only, which is nothing but Q a square divided by, okay, this is 2 pi epsilon naught. I wrote it as 4 pi epsilon naught default. Okay, 2 pi epsilon naught r cube into P2 of cos theta. This is the expression for potential at a point r, which is at a very far away distance from the charge configuration due to a linear dipole.